All right, so we're gonna have another rule of exponent called the power of a product's property. So let's suppose I have like AB to the x power, right? It's gonna be a to the x times b to the x, right? So as you can see, we distributed x, the exponent, right? The exponent for each value inside the parentheses, right? Let's take some examples here. Let's suppose I have like 3x to the x power. So it's going to be 3 squared times x squared, which is 9x squared. Let's suppose I have like a negative 4y squared. So it's going to be negative 4. Make sure you have a parentheses, right? Times y squared, which is going to be 16y squared. All right, so I have another rule of exponents called the power of a quotient property. And let's suppose I have like AB, right? So AB to the x power. So we're going to distribute the exponent for each value inside the fraction. So a to the x over b to the x, right? So when raising a fraction to a power, we're going to raise both the numerator and denominator to that power. So let's take some examples here. So let's suppose I have like 2. I have like 2 to the x, right? 2 to the x cube, right? So it's going to be like 2 to the third over x to the third, which is going to be 8 over x to the third. All right, let's take another one here. Let's suppose I have 4 over y squared, right? That's going to be like 4 squared over y squared, which is going to be 16 over y squared. Let's get some numbers here, like 2, like 2 over 5 to the third power. Now this is going to be like 2 to the third over 5 to the third, which is going to be 8 over 125, right? All right, another property here of exponent. Every non-zero number raised to the 0 power is always 1, right? And for example, if I get like x to the 0 power always would be 1, right? If I have like 3 to the 0 power, always would be 1, right? So let me get some like, different color here. All right, let me just get different color. All right, so means like 3. So 3 to the 0 power, always 1. If I got 100 to the 0 power, always would be 1. What if I multiply like 5 times x to the 0 power? Right? That's going to be like 5 times, x to the 0 power is 1, right? It's going to be a 1, and the answer is 5. But what if we have this? We have 5x and everything to the 0 power. So in this case, the answer is 1, right? So, a second, right? Because we're going to treat inside the parentheses, right, as a non-zero number raised to 0 power, right? So it's like a to the 0 is like x to the 0. So everything in the parentheses will be raised to the 0 power, and the answer is going to be 1. And what if we have this? We got like 3, right? 3x squared. I'm sorry, 3x to the 0 power 3x to the 0 power, that's going to be also 1, right? But if I have 3x to the 0 power, that's going to be 3 times 1, 3 times 1, and that's going to be, it's going to be 3. It's going to be 3. All right, another rule of exponent called even or odd rule. So let's start with number 1. Negative base raised to an even power is always positive, right? If I have, because if I have, for example, 2, if I have like negative, if I have like, negative 2, right, to the 4th power. So we're going to expect to have a positive value because 4 is even. 4 is even right here, right? Because we know that negative 2 to the 4th power is going to be, it's going to be negative 2 times negative 2 times negative 2 times negative 2, right? And negative times negative is positive. Negative times negative is positive 4. And negative times negative is positive 4. And the answer is 16. Right? So, the same thing if I have like another number here. Let's suppose I have like, so I have like negative 1 to the 6th power here. We're going to expect to have positive value. And the answer is going to be 1 because 1 times 1 times 1, like 100 times, is going to be always 1. So the answer is just going to be, a 1, right? If I have like negative 1 to the 14th power, the answer is going to be 1, right? And the same thing here, if I have like, let's suppose I have like negative 3 squared, the answer is going to be positive because 2 is even. So it's going to be like negative 3 times negative 3 is going to be, the answer is going to be 9, right? And if I have like negative 3 to the 4th power, the answer is going to be positive because 4 is even. So the answer is going to be negative 3 times negative 3, like 4 times, and it's going to be 81. It's going to be 81. Let's now take another rule. Now, if we have a negative base raised to another power, the answer will be negative. And let's take the same example, the same base like we had before. Let's suppose I have like negative 2, and instead of to the 4th power, let's suppose we have negative 2 to the for example, to the 3rd power here, right? Now we know that that 3 is odd number, right? So it's going to be like we're going to expect to have negative value. We're going to expect the answer will be negative, right? So negative 2 to the 3rd power, that's going to be negative 2 times negative 2 times negative 2 3 times, right? And we know that negative times negative is positive. 2 times 2 is 4. And times negative 2, right? So positive times negative, that would be negative. And the answer will be negative here, negative 8. Right? If I have, for example, negative 1, well, to do negative 5. So the answer is going to be, negative 1. Why? Because we know that negative times 5 times is going to be, 1 times 5 times is going to be 1 anyway. So, but the answer is going to be negative because we have the exponent here. The exponent is odd. Right? If I have like negative 1 to negative, well, let me correct this. Sorry, what I meant here is to the 5, not to the negative 5. All right, so it was a mistake here. That was 5. Sorry, it's going to be like negative to the 5. So 5 is odd. 5 is odd right here. So as you can see, 5 is odd right here. So the answer is going to be negative 1. The same thing here. If I have like negative 1 to the 13, right? Negative 1 to the 13, the answer always is going to be negative 1, right? So when we have a negative base raised to an odd power, the answer is always negative. All right, another property of exponent here. To change the sign of an exponent, move it along with its base across the fraction bar. And I believe I gave example before to this one here. So let's suppose I have like x to the negative third, right? So it's going to be, if you want to change the negative exponent to positive exponent, right? So we're going to move, right? We're going to move the sign across the fraction bar. So we're going to be like 1 over x to the third, 1 over x to the third. And the same thing if I have x to the negative 3, right? I will do the same thing. It's going to be like 1 over, it's going to be 1 over x to the third. Oh, sorry, if you have, that was the same example. If I have like 1 over, let me change this one here. Seems like I gave the same example, right? If I have like 1 over x to the negative 3 here, right? So it's gonna be x to the third. It's gonna be like x to the third. All right, so let's take some examples here. Let's suppose I have like 2 to negative 3. So it's gonna be 1 over 2 cube, right? It's gonna be like 1 over 8. And let's suppose I have like 1 over 2 to the negative 3. That's gonna be 2 to the third, and the answer will be 8. All right, so what if we have this? What if we have like, we have like x over 4 to the negative 2. So in this case, right, we're gonna flip the fraction, right? We're gonna change x over 4 to its reciprocal, which is gonna be like 4 over x squared, right? And in this case, we're gonna distribute 2 to 4 and x. It's gonna be like 4 squared over x squared, and the answer will be 16 over x squared, right? So in general, if you have like a over b to the negative x, it's gonna be like b over a to the x power. So you're just gonna flip. You're gonna flip the fraction, right, to its reciprocal. Let's take another example here. It's gonna be, let's suppose I have like 3 over, right, over 4 to the negative 2. So that's gonna be like 4 over 3 squared, which is gonna be 4 squared over 3 squared, and the answer will be 16 over 9.